Hi everyone, it's Miss H, and today we're going to be looking at types of bonds. So the first type of bond we want to look at are ionic bonds. Ionic bonds are formed when electrons are transferred from the cation to the anion. The cation will typically be a metal, although it could be ammonium, which is a type of polyatomic ion, and we'll talk more about those on another video. And if you are in a more advanced class, you might have other cation polyatomic ions to look at, but in a basic introduction physical science class, the only cation we're going to look at is ammonium. The anion is usually a nonmetal, although again, it can be a polyatomic ion. Most of you will have a list of polyatomic ions provided for you that you could look at to figure those out as well. But again, the key for an ionic bond is that the electrons are transferred from one atom to another. This causes the atoms to become ions that have a positive charge and a negative charge, and since positive and negative are attracted to each other, a bond is formed. Because these ions are equally attracted to anything with an opposite charge of them, it is easier to break an ionic bond than some other bonds because they will equally attract to something else. So they're just as likely to bond to one atom as they are to another atom that has the same opposite charge. The second type of bond we want to look at are covalent bonds. Covalent bonds form when electrons are shared between nonmetals and occasionally metalloids. There are two types of covalent bonds. The first are nonpolar covalent bonds. In a nonpolar covalent bond, the electrons are shared equally. So atom A gets it for 50% of the time, atom B gets it for 50% of the time, or 33, 33, 33, or 25, 25, 25, 25, whatever it is kind of that it has. Now, sometimes you have electrons that don't share, atoms that don't share electrons equally, and we call those polar covalent bonds. When the electrons are not shared equally, we call it a polar covalent bond. So one gets it 70% of the time, and the other one gets it 30% of the time. So these are going to have a partial charge. So ionic bonds have a very strong division in charge, and polar covalent have a weak division in charge, and then nonpolar covalent don't have a division in charge. It's all kind of got the same charge. Remember that it's not exactly necessarily black and white. Like most things, there's more of a spectrum, but that gets into more details than we're going to be concerned with in this class. Again, this is a video for like an introduction level. So the bonds in a covalent bond are a little bit harder to break because they're sharing. So they're not going to be as attracted to other atoms. And the more electron pairs that are shared, the harder the bond is to break. So a single covalent bond is easier to break than a double covalent bond, which is easier to break than a triple covalent bond. And it's impossible to have more than a triple covalent bond because the maximum number of bond pairs that you can have, or paired electrons you can have, is 3. The final type of bond we're going to be looking at in this class are the metallic bonds. So metallic bonds form when electrons are shared between metals. And so they're not shared the same way they are in nonmetals. So you can think of ionic bonds and covalent bonds as kind of a tug of war, where in a ionic bond, there's a clear winner and a clear loser, and in a polar covalent bond, there's some back and forth, but one is probably going to end up winning over the other. And then in a nonpolar covalent, it is like, your clone, you are 100% equally matched. There's no way that either one of you can win. Metallic bonds are different. They don't have this kind of tug of war. Instead, it's everybody takes what they need and puts it back when they're done. So instead of sharing the same way that they are in a covalent bond, metallic bonds share a little bit differently. Metallic bonds are how metals share electrons again. You can sometimes have nonmetals and metalloids involved, such as in the formation of steel, but you have to have metals sharing their electrons with something else in order to have a metallic bond. If the metal gets rid of its electrons, that's an ionic bond. When the metals share electrons, that's a metallic bond. So electrons are shared as kind of a pool where, again, everybody puts in their electrons when they're not using them and takes them out when they need them. And this is the bond that allows for the pure metals to be held together, as well as for the formation of alloys like steel, brass, and bronze. There is one other type of bond called a hydrogen bond that we're not going to talk about in this class, but I'm sure that you can find other videos explaining how hydrogen bonds work. These are just some fun graphics. You can see the credit to who the creators are on the screen as well, that just kind of show you some of the differences between the different types of chemical bonds. The last thing I want to look at are the polyatomic ions that I mentioned at the beginning with our ionic compounds. So poly means many. That means that polyatomic ions contain multiple atoms. Polyatomic ions are involved in ionic bonding. So if you have a polyatomic ion, it is going to be either the cation or the anion involved in the ionic bond, but they themselves are held together through covalent bonds because they are nonmetals that are sharing electrons. Polyatomic ions are treated as a single unit, and so we typically will write them in parentheses with their ion charges on the outside. And when we are adding in counts to tell us how many copies of that polyatomic ion are in the compound, it will go on the outside of the parentheses. You won't see the parentheses written when you're looking at polyatomic ions that there's only one copy of, typically, just because that's the convention. But for an introductory level class, I recommend that you go ahead and write them in parentheses all the time, just for the sake of making it easier to see where that polyatomic ion is. And so that you remember to treat it as a single thing instead of trying to break it into its parts. And again, in the class that you're going to be taking, you should be provided with a list of polyatomic ions on a reference table. I hope that this helps and to answer your questions about types of bonds, and I hope that you have a great day.